We've spent a lot of time with graphs, and now we want to double back and look at tables a little bit more in depth. Now it says continuous data, and that's true. It will be with decimals most of the time. But honestly, this what we're about to learn will hold true even if it's just the numbers being put into groups, also known as bins, right? When you bin your numbers or group your numbers. Okay, speaking of which, the bins themselves are called classes. So those are the categories by which the data are grouped. When a data set consists of a large number of different discrete values, or, right, so that's what I was saying, a large number of discrete, or the data set has continuous data, i.e. decimals, we will put them into groups and create classes. Another word for classes is bins, right, and using intervals of numbers. Okay, so let's just look down here for a second. So we have an example. This is the Pew Research Center gathered a random sample of TikTok users and recorded their ages. So, and yes, this is real data. So you can see the ages are grouped, right? They're put into groups, ages 20 to 29. Technically, it's 29.9, right? All the people that are in their 20s are in this group. All the people in the 30s are in this group. So it's continuous data because it actually does have decimals, but it also is grouping all of those ages together. These are the classes. This is the first class, which is below 20, the second class, which is 20 to 29, third class, fourth class, and fifth class. So there are 5 classes in this one. And if you're interested, you can say first class, right? These are the classes over here, second class, and so on. Okay, well then those classes have limits. They have a lower class limit, which is the smallest value within a class, and they have an upper class limit. Now, to be honest with you, the upper class limit is rounded most of the time. That's because most of the time you're dealing with continuous data, and so it's rounded. So in this case, for example, if you are a day before your 30th birthday, you would go into here. This is really 29.999. We've just rounded it to 29. We rounded this to 39, and so on. So this is the lower class limit. Actually, if I look here, I'm going to skip letter B for a second. The lower class limit of this class is, the second class's lower class limit is 20. Right? You can see it right there. That's the lowest number that is in that class. Once you have your 20th birthday, you're in this class. Once you have your 30th birthday, you're in this class, and 40th, and so on. So I know I'm skipping ahead here, but you can see the third class's upper class limit. So 1, 2, 3, the third class is right here. So its upper class limit is 39. Or if you wanted to think of it, it's really 39.9999 going on forever, right? We just round it to 39 until you hit your 40th birthday, in which case then you pop into here. So that's how lower class limits, the lower class limits are on the left, upper class limits are on the right. Okay, what about the beginning and the end though? What's going on there? Well, those are called open-ended classes. When the first class has no lower class, or the second class, or the last class has no upper class limit, which actually both of those are taking place here. This is open-ended, and so is this, right? Because this has no bound on the low end, and this has no bound on the upper end. So both of these are open-ended. So I'll make a little note here. Because of the below, that's open, right? Open-ended. And so is this. The and over right there makes this one also open-ended. It's the fifth class, and the fifth class is open-ended. It doesn't have an upper class limit, and the first class does not have a lower class limit. All right, what about the class width? Well, the width is often it's the difference in consecutive lower class limits. And I cannot stress this enough because students really mess this up on a regular basis. It's very simple. It's not what you think it is. So the width is not from 20 to 29. It's from 20 to 30, right? Because it includes all of these numbers. So if you start at 20, 20, 21, 22, 23, 24, that's 10 numbers in there. It's the difference from here to here to here. If you look at lower class limit 20, next lower class limit's 30, next lower class limit's 40, next lower class limit's 50, those are all going up by 10. So the class width if you will, is 10. Make a note to yourself, right? The reason it's happening is because you're going from 20 to 30 to 40 to 50, right? They're all 10 apart. And the way I wrote it is the difference, i.e., subtraction, in consecutive lower class limits. Consecutive means one after the other. In other words, if you took 30, here, let's write it that way. 30 take away 20 is 10. That's why it's happening, right? Or 40 take away 30, or 50 take away 40. They're all 10 apart. That's why 10 is the class width, excuse me. Make sure you do it that way. All right, now what about the modal class? The modal class is just the class with the highest frequency. If you ever remember learning in school mean, median, mode, this is the class that's the mode. It's the class with the highest frequency. That's all it is. So in this case, the highest frequency is 20 to 29-year-olds. So 20 to 29 is the class. And the reason it is because it had the highest frequency. All right, so we learned a bunch of new definitions, but we still have some old ones. I know I've skipped over A. So A was saying, hey, find the totals and the relative frequencies and place them in the table. Well, we're going to learn a different way for doing this in the next section, but for right now, we're just going to use Desmos. So we make Desmos add 403 plus 564 plus 306 plus 210 plus 139, and we get a total of 1622. And then we're going to want to find all of these values divided by that total, because that's how we find relative frequency. We take the frequency and we divide it by the total. And we would round all of these to 3 decimal places because that's what it said to do. Oops, 139 over 1622. All right, there we go. So I'm going to copy over the total of 1622, and I'm going to round these. So 248, and then 348. And then 189, right? That 6 is higher. So we go 189 for the third one, 129, and 0.086, because the 6 would round that 5 up. And before I go write these on my paper, I actually want, well, I am going to write them on my paper, but I also want to know if they add up to 1. They might not because of rounding error. So I'm just going to add these up really quickly. Oh, and they do add to 1 this time. So that's great. Okay, so I put them all on my paper, and I have a sum here. The total is 1622 for this group. Then I found all these to 3 decimal places. You do not have to show the fraction. I was just showing it for that once to remind you and your notes how you find these values. But we really just need the decimals here. And then we added them up and we found 1. So we found the totals and the relative frequencies with 3 decimal places and placed them in the table. We found both totals. All right, what was little n? Well, little n is the sample size. So sample size. And that was 1622. There was 1622, and it was a random sample of TikTok users right here. So it was 1622 TikTok users in the sample. If you'd like, you can say in sample, but that's implied. So, all right. Now, what about age? The age of a TikTok user is what type of variable? Well, age is always continuous. That's because you're not really the age you think you are. So when you say, for example, I'm 51 years old, but you're not. What you are is 51 years, 3 months, 7 days, etc. Right? So you're really 51.2643. There's decimals, right? And every second that ticks by, you get different decimals over here. But you do have decimal ages, and it goes right up to 51.99999 on the day of your birthday, right? And then the clock ticks over and makes you 52 when you turn 52, right? That's how it works. So there are decimals with your age, right? It has decimals because you're aging every single moment that passes. So your age over here has decimals to it. All right, how many TikTok users were sampled, or excuse me, users sampled were 40 or older? Okay, how many? How many is a frequency question, right? That's going to be a whole number. So this is going to be frequency. Okay, so let's look at the ages here. 40 and older is these two groups. So we're going to add up how many there were in those two groups, right? So 210 plus 139 makes 349. Now, that's very different than I, because letter I is asking what percent of TikTok users were below 30 years old. So percentage is a decimal, right? And they want one decimal place on that percentage. Okay, so 30 or below, sorry, below 30 is these two, not 30 or below, but below 30 is these two, which is these two, right? So we could add up, and you can do this two ways. You can add up the 403 and the 564. So let me put those two together. 403 plus 564 makes 967. So you could take 967 and divide it by 1622. Or you could take the fact that you already know it's 248 and 348 and add those up, and you'll get the same answer. And they could be slightly different due to rounding error, but that did not happen. So down here, we have to make a choice. So you could say 403 plus 564 makes 967. You're going to divide that by the total. Or, well, which will give us a decimal, right? 0. I forget what it was now. Well, I have to go back. 0.596. 0.596. Or you could take 0.248 plus 0.348 and also get 0.596. So either way, you're going to get that. Now that's not the answer because they asked for a percent. These are decimals, not percents. So to make it into a percent, we have to move the decimal 2 spots to the right, and we would get 59.6% either way, right? Either this one or this one would get us that answer. And you can just choose to do one method or the other depending on what feels more comfortable for you. And you'll notice they wanted one decimal place for that percent because we have 3 decimal places for the relative frequency. So 3 decimal places for the relative frequency got us 1 decimal place for the percent, which is what we were looking for.